Namaskar, my dear friends. Let us try to understand how we can plot transfer function in MATLAB for any electrical circuit. Okay, so this is the circuit that is given to us, and our aim is to find out the transfer function Vc of s by Vs of s, that is voltage across capacitor to the voltage across the source, right? So this is my source voltage. We have to find out the voltage across capacitor by voltage across source, that is the transfer function in MATLAB, right? So first of all, we'll try to understand how we can find transfer function in MATLAB. So what you have to do is, let's say we have a transfer function system 1, which is going to be, let us say, 1 by s square plus s plus, let's say, 4. Okay, so you have to put it in transfer function in MATLAB as numerator comma denominator, and this is going to be TF. So TF of numerator denominator will give you the transfer function in MATLAB. Okay, what is the numerator here? So numerator will be the coefficients of numerator in the system, which is going to be 1. So put it in big bracket. Okay, and denominator, that is also going to be the coefficients of denominators, which is going to be 1 1 4. So how did I get 1 1 4? Is the coefficients of s square, then s, then 1, and then the coefficients, that is 1. Okay, that is 4. Now the understanding is, you have to make sure the denominator or the numerator should be in decreasing order of the powers. Okay, so that's the understanding. Now what we'll do is, we'll try to open MATLAB and we'll see how it works. So this is my system, that is going to be system 1, which is TF numerator comma denominator. If you want, you can put numerator equal to whatever the numerator is there and denominator equal to that, and it will give you the answer. Instead of that, what we can do is system TF of, this is the numerator coefficient, which is 1, and denominator coefficients 1 1 4, and you put a figure and you put your responses. Okay, so let us first run this and find the system, how the system looks. So once I run it, what happens is, my system is TF, which will be shown. Okay, so let us put this step response. So I am going to put here uncomment. Okay, so once you uncomment it and you run it, you are going to get your step response of this particular system. So what is happening? The system is going to be transfer function of 1 comma 114, which is going to be 1 by s square plus s plus 4. This is how it is displayed, and you can see this is my step response. Okay, got it? If you want, you can put a impulse response also. So impulse response, what will be there is, I'll just put it like this and make it comment. Okay, so once I run it, you are going to get impulse response of this. Okay, so I'm not going to explain you how the step response looks like, how the impulse response looks like, and all these things. We will do that in later. Okay, now our aim is to understand how we can solve our particular circuit, and we can find the transfer function of this particular circuit in MATLAB. Okay, so first of all, we will convert this circuit in time domain to frequency domain. Okay, so let us say, you know already that R in frequency domain is R only, that is resistor, L in frequency domain is SL, and C in frequency domain is 1 by SC. Got it? So using this, we are going to put that one. So SL, this is going to be R, and this is going to be 1 by SC. And my Vc of T, that is voltage across capacitor, will be Vc of S, and the source voltage will be Vs of S. Okay. Now, to get the transfer function, our aim is to find out my Vc of S, which is going to be in terms of Vs of S of this thing. So you know already the voltage division rule. Using that, we can solve it quickly. Okay. So what will happen? My Vc of S will become R parallel 1 by SC of Vs of S. Okay, this is my source voltage. Got it? Divided by total resistance, which is going to be SL plus R parallel 1 by SC. Understood? So this is so simple. Now, if we solve it quickly, what we'll do is, we'll quickly find out R parallel 1 by SC. Okay, so this is going to be R into 1 by SC divided by R plus 1 by SC. So this is going to give me, SC will get cancelled. So this is going to be R by 1 plus SRC. Okay. So we'll replace with that. This is going to be Vc of s will be equal to R by 1 plus SRC divided by SL plus R by 1 plus SRC. Understood? So this is the complete, like a transfer function into Vs of s. Okay. Now after solving again, what we are going to get, if we do little bit more solution, Vc of s will bring this Vs of s down. So this will be my transfer function, let us say T1, which is going to be, what will happen? Tell me, 1 plus SRC will get cancelled. So that will become just R by, this will get multiplied here, right? So this is going to be SL plus S square RLC plus R. Now can we do one thing? We can divide this by RLC so that we can have the coefficients, okay, separately. So what will happen? R by RLC divided by all RLC. If you do, then it is going to be S square plus this is going to be S by RC and this is going to be 1 by LC. And RR will get cancelled. So upper one is also 1 by LC. So this is going to be 1 by LC divided by S square plus 1 by RC into S plus 1 by LC. So this is my complete transfer function. Okay. Now you know what is my coefficients of numerator and denominator. So numerator coefficients are 1 by LC and denominator coefficients are 1, 1 by RC, 1 by LC. If you know the value of RLC, you can find out your transfer function into numerator and denominator in the MATLAB. Okay. So let us quickly do this. This is a very good understanding how to find the transfer function of any electronic circuit in MATLAB by solving the transfer function Vc of s by Vs of s, or you can find out the, like voltage across inductor also or voltage across resistor also. Whatever way you want, you can do that. Okay. And you can write down your transfer function in MATLAB. So what will you do? Let us open MATLAB and we will do that. Let us say we are going to define some values. Okay. So R we will put, let's say 1 kilo ohm, that is 1000 ohm. Okay. Then we are going to put L, that is inductor, which is going to be, let's say 1 millihenry, 1e minus 3. So 1e minus 3 means it will tell you that it is 1 millihenry. Okay. 1 into 10 to the power minus 3, or if you want you can put 1 into 1e 10 to the power minus 3. Let me make it quick. Capacitor will put 1 microfarad, which is going to be 1 into 1e minus 6. Okay. Now what was the numerator and denominator that you guys know, right? So numerator was what was that? We had 1 by LC. So L into C. Got it? So we got the numerator. We had denominator, which was, first of all, it was what? We had 1, then it was 1 by RC, 1 by R into C, and we had 1 by LC, 1 by L into C. Got it? L into C. So we got the coefficients of numerator and denominator by calculating the given value of resistor, inductor and capacitor. This is the advantageous method because if you want, you can vary the value of resistor, inductor and capacitor. Okay. And your numerator and denominator will automatically get calculated. So you don't have to calculate each and every time and put the values. Understood? So this is not the response. You don't look into that. Now, what was the method that I had told you? My transfer function, let us say TF is my transfer function, which is going to be TF of numerator comma denominator. Okay. So my numerator is already defined, denominator is already defined, so my transfer function will be defined. If you want, you can show the transfer function so that it will give you exact transfer function that is there in the console. Okay. Now what is the next method, that next thing that I told you? you can start a figure and you can plot your transfer function. Okay, so let us say step response of my TF. Okay, so step response of TF will be shown. So let us run this and see what is the result. So see, as you can see, the step response of this particular transfer function is, with time the voltage across the capacitor is going to be stabilized to 1. Okay, and that was the expected, right? And you can see the transfer function looked like, I had to show it here. This one is this one is this. So numerator values and denominator values will be calculated and so on. So you can see numerator has only one coefficient and denominator has three coefficients. And you can see this is my transfer function, 1e to the power 9, like 10 to the power 9 divided by s square plus 1000s plus 10 to the power 9. This is my transfer function. If you want, you can put your impulse response as well. So let me just put one more figure and impulse of my transfer function. If you want, you can keep both of them together. Okay, so wait, this is my step response and this is my impulse response. So step response is this, and impulse response you can see this is going to be 0. So with time the output will become 0 in impulse response, and in step response it had become 1. So hope you have a good understanding now about how to find the transfer function for any of the circuit that you want. You can find the voltage across that particular requirement and divide it by the source voltage, or wherever the transfer function is required, you can do that and find out the transfer function in MATLAB. Alright guys, if you do have any questions or any queries, please put down your comments in the comment box and we shall be able to answer you out. Thank you.